We're now at the last learning outcome in the 3.1. Okay, so the last one should be we're talking about the turning points and the multiplicity. Oh my gosh, I have such a hard time to pronounce this word. Multiplicity of polynomial functions. So let's take a look at your workbook. It's easier for me to use the graph here. So now, for example, now let's take a look at a polynomial that is let's see this, sorry. The polynomial that is the minimum degree. This minimum degree now, this degree is 5. Now the degree of 5 a polynomial, and how many turning points it has? 1, 2, 3, 4. And then this polynomial, this is degree of 4. Now how many turning point here is 1, 2, 3. So this is trying to use just this two typical examples of the graph to explain that it says if a polynomial has n turning points and then the minimum degree is n plus 1. So I rather say something is that if the degree of polynomial function is n, then the max turning point of the graph is n minus 1. I personally feel this is much easier to understand. All right, and I do find a YouTube video that explains the reason why. Of course, you can use whole bunch of graphed by decimals to test. You can use whole bunch of graph, either the degree of 1, degree of 2, 3, 4, 5, 6, 7, 8. You can try it out until 10. And then you count all the turning point, then you realize that the turning point never can be the same as n. The maximum is n minus 1. But as I said, another YouTube video that I happen to watch explains very well and use a different graph to explain. So I will post the link if I can find that video again. All right. So this is talking about the turning point. And then we can also realize that if the n degree of n, again, if this is an odd number, if that's an odd number, and then the minimum turning point, the mean turning point, so-called turning point, well, think how much? It will be 0. Why? Because you think about a linear function that is the smallest degree, the lowest degree of our polynomial, then there's no term. It's absolutely no term. And this is 1, degree is 1, so that means it's all number, right? If you have a 3, the maximum could be cross this one here, cross this one here, and it could have different turning point, but the maximum will be n minus will be 2. All right. Now, if the n is even number, then your minimum turning point is 1. Right? So take a look at the quadratic. Yes, you must turn one time. You must turn one time. All right, and then you got a 4, you got a 6, and it's a similar thing. All right, so now let's take a look at what they call the multiplicity. Okay, so I give you an example, 2 examples. Now here we go. So if you have fx, that is x to the power of 4 plus x to the power 3, subtract 6x to the power 2. Okay, so now let's solve this. Again, the point is not how to solve it, but trying to explain what the multiplicity is all about. So over here, we factor out the power of 2. So then we got the power of 2 plus 1, subtract 6. Now factor this. That is x to the power of 2, x plus 3, and x minus 2. So now here we could rewrite this. This is x subtract 0 to the power of 2 and that and that. So therefore our roots or solution when fx equals to 0, that means x equals to 0, x equals to negative 3, and x equals to positive 2. Now note here, this degree here. Now this is, of course, as you may realize, this is 1. So these ones, so for example, if I rewrite this, called x minus a to the power of k. This k is so-called the multiplicity. And what is so important about this? This is explained in 3.2, but I can just quickly explain here. So the multiplicity, that means if the power is 1, not the power, if the multiplicity, so if the k equals to 1, that means your graph would be just definitely will cross the x-axis. So cross x-axis. Now why? Now take a look at how can we imagine this graph. This graph, we got a negative 3 here, we got a 0, and we got a positive 2 as our zeros or roots, right? Or x-intercepts, no matter what you want to say. So there's 3 points here. And also because this is the degree of our polynomial is 4, which is an even number, and also this is a positive coefficient. So our end, from our end behavior, we definitely know this is somewhere going that way, somewhere going, that's our end behavior, right? So now we're already getting into, from the turning point now to multiplicity, that what's happening in between. So not only this one maximally, this would have 3 turning points, right? So this from here will have 3 turning points. And on top of that, how they turn? Do they cross the axis? Do they bounce back? So let's see. So if the multiplicity is 1, then that means it cross, right? That means cross. So that means it is from here, it goes to here, so it will cross. You see, it will cross here. And then when we go to 0, now when we go to 0, This is 2. So when we go to 0, this is when it's 2. When k equals to 2, it does not cross. It only bounds. So when we get to 0, it does not cross, but it bounds back. And then when we get 2, it is crossed again. So this is an important thing about why we needed to understand the multiplicity of our zeros. All right? So now, so that also means if this is an even number, when k is odd number, which is like the 1, that's cross. However, the interesting thing is that if it's not 1, then this, if it's an odd number, it will absolutely cross. But if k is also larger than 1, when it crosses, it seems like it's going to bounce. But it's cross. So this part is almost give me a sense. It's like it's got some resistance, so it is longer. It's not like you just cross it here. You just cross it here, just with very determined mind, just cross x-axis. This kind of crossing, one is larger than 1. It got some kind of and then the turn. All right. Now, if k is an even number, such as 2, and it is bounces. It does not cross. It bounces. All right. And we will talking about it a little bit further in 3.2.